Hello everyone and welcome back. In this video we're going to look at some of the properties of the expected value and the variance. Now these properties are true for both the discrete and continuous random variables. So first off, adding or subtracting a constant from random variables shifts the mean but not the variance or standard deviation. And this is analogous to when we looked at how shifting numerical data affects the distribution. So mathematically, this means that the expected value of x plus or minus a constant b will be equal to the expected value of x plus or minus b. And so the mean of our random variable will change by that same constant. However, the variance or the spread will not change. So mathematically, this means that the variance of x plus or minus b is equal to the original variance. Now, if we're multiplying each value of a random variable by a constant, this will multiply the mean by that constant and the variance by the square of that constant. And this will be analogous to how rescaling numerical data affected the distribution. And so mathematically, this means that the mean of a times x is equal to a times the expected value of x. And for the variance of a times x is equal to a squared times the variance of x. And so the variance will be affected by the square of the constant. So now let's consider some examples of how these properties can be used. Now let's suppose that the average monthly income for company X's employees is $5,000 with a standard deviation of $1,000. Now the boss is kind enough to give all employees a salary raise of $500. And so what will be the mean and the standard deviation of the average monthly income after the salary increase? So let's introduce some notation. We're going to let our random variable x be the income of an employee. And we're given that the average monthly income is $5,000, so the expected value is equal to $5,000. The standard deviation is 1,000. So sigma of our random variable x is equal to 1,000. So since the boss is giving every employee a $500 raise, then we are effectively adding a constant to our random variable. And so our variable is x plus 500. So now we can calculate the mean of our variable, x plus 500. This will give us the mean of the average monthly income after the salary raise. So using the properties of the expected value, this is equal to the expected value of x plus 500. And so the original mean was 5,000. And so we add 500, which gives us 5,500. Now to find the new standard deviation, we first need to find the variance of x plus 500, and then we can take the square root of the variance to determine the standard deviation. So using the properties for the variance, we know that adding or subtracting a constant does not affect the variance. So this will be equal to the original variance. Now the variance is the square of the standard deviation, and the standard deviation was 1,000. And so the variance of x is 1,000 squared, which is 1 million. And so we can now find the standard deviation after the salary raise by taking the square root of the variance. So we want the square root of the variance of x plus 500, which we calculated to be 1,000,000. So the square root of 1,000,000 is 1,000. And so the mean and standard deviation after the salary raise is 5,500 and 1,000 respectively. Now for the next example, instead of increasing everyone's salary by 500, let's suppose that the boss decides to give a 10% increase to their salary instead. So what is the new mean and standard deviation of the average monthly salary in this case? So since the boss is giving every employee a 10% raise, then we are effectively multiplying a constant to the random variable. So we need to first determine the constant A such that when we multiply the original salary by A, then we will receive our new salary. So for example, suppose that our original salary was $1,000. This means that our new salary, which will be a 10% increase, will be $1,100. So when we multiply the original salary by A, then the new salary is going to be 1,100. And so we need to determine the value of A such that this will give us our new salary. So we can solve this equation for A. This gives us that A is 1,100 divided by 1,000, which is 1.1. So if we multiply our salary by 1.1, this will give us our new salary, which is a 10% increase. And so to determine the new mean after a 10% increase to our salary, what we're looking for is the mean of 1.1 times x. And so if we use the properties of the expected value, this will be equal to the constant 1.1 times the original mean, or the original expected value. And so we have 1.1 times 5,000, which gives us 5,500. And to find the standard deviation, we again look for the variance of 1.1 times x, and then we take the square root to find the standard deviation. So using the properties for the variance, this will be equal to the square of the constant, so it will be 1.1 squared times the original variance. And recall that the variance was sigma squared, or the standard deviation squared. So we have 1.1 squared times 1,000 squared, which will give us 1,210,000. And now we can determine the standard deviation by taking the square root. So the standard deviation after a 10% increase to our salary will be the square root of the variance. So that is the square root of 1,210,000, which will be 1100. So the mean and the standard deviation after the salary increase is 5,500 and 1,100 respectively. So now let's look at some properties for when we're adding or subtracting random variables. When we add or subtract two random variables, x and y, then the expected values will add or subtract as well. And so mathematically, this means that the expected value of x plus or minus y is equal to the expected value of x plus or minus the expected value of y. Now if we're adding or subtracting independent random variables, then the variances will always add. And so mathematically, this means that the variance of x plus or minus y will always be the variance of x plus the variance of y. And so we will never subtract their variances. So now let's take a look at an example of using these properties. So here is a table of the means and standard deviations of independent random variables x and y. So now let's calculate the mean and standard deviation of 3x. So the mean of 3x, using the properties of the mean, is going to be 3 times the expected value of x. And so using our table, we know that the mean of x is equal to 10. So this becomes 3 times 10, which is 30. So now to calculate the standard deviation of 3x, let's first find the variance of x, or the variance of 3x, and then we'll take its square root. So the variance of 3x, by using the properties for the variance, is 3 squared times the variance of x. And remember that the variance is the square of the standard deviation. So we have 3 squared times the standard deviation of x squared, which is 2 squared. And this will give us 36. And so now we can calculate the standard deviation of 3x by taking the square root. And so the square root of 36 is equal to 6. Now some of you may have noticed that we could have determined the standard deviation of 3x if we had multiplied the original standard deviation by 3. However, this will only work in some cases, and so we will go through the procedure for calculating the variance first, because this will work in general. So now let's find the mean and the standard deviation of y plus 6. So the mean of y plus 6, by using the properties for the expected value, is the mean of y plus 6. Using our table, the mean of y is 20. And so the mean of y plus 6 is 26. So now let's find the variance of y plus 6. And using the properties of the variance, this will be equal to the original variance, which is the square of the standard deviation for y. So that is 5 squared, or 25. And so the standard deviation of y plus 6 is the square root of the variance, which is the root of 25, which is 5. Now let's find the mean and standard deviation of x minus y. So the mean of x minus y is equal to the mean of x minus the mean of y. And so this will be equal to 10 minus 20, which is negative 10. Now let's find the variance of x minus y. And using the properties for the variance, we will add the variance of x and the variance of y. So this is the square of the standard deviations. So we have 2 squared plus 5 squared, which gives us a total of 29. And now we can determine the standard deviation by taking its square root. And so the square root of 29 is approximately 5.385. And lastly, let's calculate the mean and standard deviation of 2x plus 4y minus 6. So the mean of 2x plus 4y minus 6, using the properties for the expected value, this is 2 times the expected value of x plus 4 times the expected value of y minus 6. So this is 2 times the mean of x, which is 10, plus 4 times the mean of y, which is 20, minus 6, and this will give us 94. So now let's find the variance of 2x plus 4y minus 6. Using the properties of the variance, this will be equal to the variance of 2x plus 4y. We know that adding or subtracting a constant does not affect the variance. And now we use more properties of the variance to write this as the variance of 2x plus the variance of 4y. And we know that multiplying by a constant, we have to square that constant. So we have 2 squared times the variance of x plus 4 squared times the variance of y. And so this becomes 4 times 2 squared plus 16 times 5 squared. And this will give us 416. And so now that we have the variance, we can now determine the standard deviation by taking its square root. And so the square root of 416 will be approximately 20.296. And so this will conclude our lesson for this video. In the next video, we will look at some of the properties for continuous random variables and continuous probability distributions. And I'll see you then.